In this lecture, we're going to look at properties of regular polygons. We're going to start by having a quick review of what a regular polygon is. Then we're going to discuss how to identify the number of diagonals, the value of the exterior angles, and then the interior angles. Just as a review, a regular polygon is one that has equal sides and equal angles. For us to find the diagonal of a polygon, the number of diagonals, we need to first identify what a diagonal is. So a diagonal is a line segment from one corner to another corner of the polygon, but not the edges. For example, if we look at this square ABCD, the line from this side over to this side will not qualify as a diagonal. So this is not a diagonal. Okay, so a diagonal always has to stretch from one end here, the one corner right here, which is from B, to another corner D. And so if we wanted to find the number of diagonals that a polygon would have, if we say the diagonal is n-sided, we will say that the number of diagonals is n, so which is the number of sides multiplied by the number of sides minus 3 divided by 2. So let's go ahead and walk through some examples. What is the number of diagonals in an octagon? An octagon is a polygon with 8 sides, so n is equal to 8. So the number of diagonals is always going to be the number of diagonals is equal to n multiplied by n minus 3 divided by 2. So this is going to give us 8 multiplied by 8 minus 3 divided by 2. So this is 8 times 5 divided by 2, which is going to give us, we divide 2 here, 1, we divide 8 by 2, we get 4. 4 times 5 is 20. So an octagon is going to have 20 diagonals. How many diagonals does a polygon with 23 sides have? So we say n equal to 23. So number of diagonals is going to give us n multiplied by n minus 3 divided by 2, which is 23 multiplied by 23 minus 3 divided by 2, which is going to give us 23 multiplied by 20 divided by 2. So 2 divided by 2 is 1, 20 divided by 2 is 10, so 23 multiplied by 10 is 230. So we're going to have 230 diagonals in this polygon. Now let's look at exterior angles. So the exterior angle is the angle between any side of the shape and a line extended from the next side. So if we look at this right here, your external angle right here is the one that is formed at H, so we can call it EHJ. So to find the size of an external angle, you will divide 360 by the number of sides of that polygon. Let's look at some example. What is the value of each of the exterior angles of a hexagon? So exterior angle is going to be equal to 360 degrees divided by n, where n is the number of sides of the hexagon. A hexagon has 6 sides. So we have 360 degrees divided by 6. So each external angle is going to be it will have a value of 60 degrees. What is the value of each of the exterior angles of a polygon with 15 sides? So then the value, let's say x, is going to be equal to 360 degrees divided by n. Here, n is equal to 15. So x is going to be equal to 360 degrees divided by 15. When you divide this, you will get 24 degrees. So for this polygon with 15 sides, each of the exterior angles will be 24 degrees. Now let's examine interior angles. The interior angle is formed between any two sides of the polygon. So you can see here in this shape, this polygon, we have ABC. The interior angle is formed between AB and BC. Now, to find the value of the interior angle or the internal angle, we can say, first of all, we can get the value of the external angle, which is 360 degrees divided by the number of sides, and subtract from 180, because if I draw a dotted line here, we can see that this is a straight line, so it's going to be a straight angle of 180 degrees. So you have that option. The other option is you can multiply 180 by the number of sides divided minus 2, and then you divide it by the number of sides. So we're going to walk through some examples and show both approaches. What is the value of each of the internal angles of a nonagon? So with a nonagon, n equal to 9. So we're going to try two methods here. Method number one is we're going to start off by finding external angle. External angle is going to be 360 degrees divided by n, which is 360 degrees divided by 9, which is 40 degrees. So internal and external angles are supplementary angles. So what we get for the interior angle or the internal angle is going to be 180 degrees minus 40 degrees, which is going to give us 140 degrees. So that's method one. Method two, we have 9 sides. So the interior angle is going to be 180 degrees multiplied by n minus 2 divided by n. So this is going to give us 180 degrees multiplied by 9 minus 2, and then you divide that by 9. So this is 180 multiplied by 7 divided by 9. This is going to give us 20 degrees multiplied by 7, which is 140 degrees. Final example, what is the value of each of the internal angles of a polygon with 15 sides? So n equal to 15. Method 1, we're going to look for the external angle first. So external angle is going to be 360 degrees divided by n, which is going to be 360 degrees divided by 15, which will give us 24 degrees. So our internal angle is going to be 180 degrees minus 24 degrees, which is 156 degrees. Let's look at method number 2. Method number 2, the internal angle is going to be equal to 180 multiplied by n minus 2 divided by n, which is 180 multiplied by 15 minus 2 divided by 15. So this is going to give us 180 degrees multiplied by 13 divided by 15. So if we divide this through, so 15 goes into itself once, goes into 180 12 times. So 12 times 13 is 156, and then we have the degrees. So this is to show you that regardless of which one you prefer, you always get to the same answer. So these are the main properties of regular polygons that we'll address in this topic.